Now, not all quadratic functions will come with terms that has GCF, like 5 and 60, both of them are divisible by 5, and therefore we can take out the GCF here. Or for the next example, you don't always get questions that comes with a GCF between those two numbers. Like in this case, we cannot just take away, in this case, we will be able to take out the GCF 7, but it is not the case all the time. Looking at example 4, we have a fraction. Like I know some of you find it difficult to work with fractions, but this is just part of the pre-calculus 11 concept. You need to know how to work with fractions. So I'm going to take out 1/3 as a GCF, and then the plus 10 at the end once again is a constant. It is not part of the perfect square. We are going to leave it outside at the very end. So I'm going to take away the 1/3 from the first two terms, and the plus 10 stay outside the bracket. Now, once I take out 1/3 from the first part, I got x squared. That's pretty straightforward. But the problem is, as I take away 1/3 here from the 4, what do I end up with? Now, this is not an easy question to answer, but if you can ask yourself, what would you multiply to get your number back to a 4? That probably would be an easier way to approach. Now, knowing 1/3 is just 1/3 is just 1 divided by 3, I need to pick a number so that this number times it by 1 over 3 will give us a 4. So in this case, I will come up with a 12. A better way to consider this is to have 4 divided by 1/3. And use your calculator. 4 divided by 1/3, that shouldn't be a difficult task. You will end up with 12 right away. And once I have x squared minus 12x, I need to complete the square. I need the perfect square to complete the square. And this perfect square will be 6 squared. 12 divided by 2, using this middle term, and that will give us the number you use for the perfect square. And once I've added 6 squared to it, I will offset the change, and I'll offset it for this many times because of the 1/3 at the front. So now the 3 terms inside the bracket will create a perfect square, and at the end, 36 times it by 1/3, that's 36 divided by 3, or 12, and up. 10 minus 12 will give us minus 2, and we will see this vertex at 6 and negative 2. So if I'm to make a quick sketch, 6 and negative 2, here is my vertex, and if I have a positive parabola, this is a parabola that opens up with a size that is 1/3 the original, and that means it goes wider. I'm expecting a parabola that looks like this, giving us a minimum point with y equals negative 2, as this is the y coordinate for the vertex. And the x value at this point is x equals 6. So this is, I would say, one of the 2 difficult numbers, type of numbers that you may end up dealing with. It could be fractions, or it could be decimals. But the concept will still be the same. We will consider this decimal number as just some regular value, take it out as a GCF, and we are just still going to leave out the plus 3 at the end. It is not part of the perfect square. As you factored out negative 0.25 from the first term, we will just end up with x squared. And for the middle term, as we've factored out the negative, the plus here becomes a minus. And as we divide 0.25, as we take out 0.25 from the 2, we will end up with 8x for this middle term. Now once again, you can try to open up the bracket and see if 0.25 times it by 8 will give us 2. Now we need to complete the square. We need to add this extra term to it, and we need to offset the change. I'm going to add 4 square and subtract 4 square at the end with this many times. So the whole thing becomes negative 0.25 x minus 4 square, and these constant will give us, well, use your calculator, 16 times it by a quarter, so that gives us 4. So 3 plus 4 gives us 7. And that means I will see my vertex at 4 and 7. With a parabola that opens downward, I will see a parabola that is approximately here, open down, giving us a maximum. We will see this as a maximum point with y equals 7, and it happens when x equals 4. So that's the entire lesson for today. Make sure you try the questions on page 192 in your textbook, the hardcover one, not the one in the workbook. For those of you who got your workbook, these are not the questions in the workbook. These are the ones in your hardcover textbook. So make sure you try these questions, and if you have any problems finishing them, come and see me in the morning or during lunch.